As we were talking, I would be teaching you what numbers and expressions are. So let's see what an interpreter can do. Let's say you want to do some kind of calculation, and you can use your any kind of number over here. Let's say, for example, 2 plus 2 and gives you out 4. You can even take big numbers. Let's say for 1, 2, 3, 4, 5, 6 plus 6, 5, 4, 3, 2, 1, and it will still give you out a number. That's the reason because Python is made that way to handle large numbers. If you use any kind of Python, previous version of Python like Python 2.7.9, and once you cross a 6 to 7 digit number, it will give you out back as 10000L because it is a long integer. But over here in Python 3.4, the L is terminated and it only uses as much big number as you are. Let's say, for example, if I go ahead and open the Python 2.4, 2.7 terminal over here and other out like 1 lakh or blah 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 L, or it will show it as 1000. It will show us as the number, and in the end it will show it as L because it is a long integer. But if you do the same over here, it won't be the same because in Python 3.4 they have terminated the L and they will show you as much big number as it can because it is programmed to be that way that it can handle large numbers. Python 2.7.9 can do handle large numbers, but still it shows as L to prove that it's a long integer. That's the reason. And if you want to know the difference, a small difference in which I taught you right now, over here we write as print hello world. It gives out the statement, and if we just write print and without parentheses we write hello world, it will give out an error. But if you do the same over here, print, okay, just a moment, print hello world, it will just print it out. It does not need any kind of parentheses. That's the difference between 3.4 and 2.7.9 that I was showing you right now. So now we have seen what a simple, we can add up simple numbers over here. What about big numbers? What about division, subtraction, multiplication? Yes, we can even do that. Besides, we can even go ahead and calculate floats and integer. And if you don't know what a float is, then a float is something which has a decimal number. Let's say, for example, if you write 1.0000, this is a float and it is an integer. But if you write something as 1.0.12456, this is a float. Anything which has a decimal is called as a float in programming language, and anything which does not have, it is called as an integer. So let me show you how these integers work over here. Okay, let's say, for example, we divide 1 divided by 2, we get this float that's 0.5. But what if we want this in an integer format? We just use the divide symbol twice and we write it, and it will give us the integer because it zeroes down whatever it gets after period. So if you write like 9 divided by 3, you get 3.0. 9 divided by 3, you get 3 because it converts whatever it gets, it converts that into an integer. You will not see any kind of period or any decimal over there because when you use two division sign, it just goes ahead and converts that into integers. That's the reason. Let's say, and we can also calculate reminders over here for undividable numbers. Let's say 10 divided by 3, you can write 3.333. That means that it is not fully divisible, it still has a reminder. Then we can write, and if you want to know what the reminder is, then you can just write 10% 3. It will give you out the reminder. Yes, it's that easy. If you want to calculate, let's say multiply 2 into 3, it gets you 6. But if you want to go ahead and calculate an exponential, then you just have to write 2 the same times 3. It will give you out 8. And interpreter also has a quality that you can go ahead and even calculate hexadecimals. I would not be going deep into that, but just to show you what a hexadecimal looks like, it's 0 into AF. It gives you out the number 175. We won't be needing that much as of now, so I just wanted to show you that it is